Today's lesson, lesson 4.1, will be on basic inequalities. The learning goal is I can identify possible solutions for inequalities. For more information on basic inequalities, you can refer to IXL T.1 in grade 7. The book also has, on page 484, inequalities. This lesson today will be broken up into 2 days. The textbook covers this in one. In the textbook, this is 11.4. Now, in our previous chapter, we covered equations. The left side is the right side. The two things are equal. Now, in this chapter, we're going to be covering inequalities, which says the two things are not equal. You can see there's 5 on the left side and 4 on the right side. Some jokes to start us off. Harold, did you order something online? You idiots, we'll never get that thing down the hole. Let's start with our daily review. 5 parentheses x plus 3, close parentheses, plus 2x equals 57. Think about what we start with first here. Distributive property. Distributive property says I can multiply the number outside of parentheses times the number on the inside. I get 5x plus 15. Next, I bring down my 2x, and that's equal to 57. Next, I look for things I can combine. I get 7x is equal to 15, or plus 15 is equal to 57. Now, what do we do next? This is a two-step equation. I'll begin by drawing a line through my equal sign, subtracting 15 from both sides. You get 42 on the right side. Then I bring down my 7x. So now I have 7x is equal to 42. Again, feel free to pause the video if you need more time. Next, I draw my line through my equal sign again. Understand that I'm multiplying, so therefore I have to divide. And I get x is equal to 6. So my answer is x is equal to 6. Number 2, write out the inequalities. Inequalities are these guys right here, or less than, or greater than signs. And then circle which statements are true. Take a minute and write down these inequalities. The first one says 7 is less than 6. Well, 7 is definitely not less than 6. So that's not correct. For B there, it says 7 is greater than 6. Okay, well 7 is bigger than 6, so that's correct. For C, it says negative 8 is greater than negative 7. Well, if I look at a number line, I can see that the negative 7 is closer to 0. When we're dealing with negatives, a number that's closer to 0 means that it's bigger. Or maybe you just remember that negative 7 is in fact larger than negative 8. So that one would be not true. Number 4, negative parentheses, subtracting negative 8 equals 8. I remember that when I have minus and negative, that's the same thing as adding. So I end up with 8 plus 8 is equal to 8. Well, that's true. 8 is equal to 8. Of course, this is not an inequality. What do we call this sign here? Well, it's an equal sign. A book contains 240 pages. Travis plans to read 16 pages per day. How long will it take Travis to finish the book? So what are our important words here? Well, if we think back to our math in the words paper, we can see that the word per is in this problem. Also think about what the question is asking. How long will it take Travis to finish the book? Since per means divide, we're going to go ahead and divide. 240 will go inside the house, and the 16 will go on the outside. 16 can't go into 2, but 16 can go into 24. 16 times 1 is 16. Subtract 24 from 16, that's equal to 8. Next, I bring down my 0. Now I have 16 into 80. I think about numbers that could possibly go into 80. Why don't I try 16 times 4? 16 times 4. 6 times 4 is 24. Plus 2 is 64. Well, that doesn't work. But if I notice that I have 16 more, that's going to give me 80. But just to double check, I'll do it anyway. 16 times 5. 6 times 5 is 30, plus 3 is 80. So how long will it take Travis to finish his book? It will take Travis 15 days. Number 4. What is the prime factorization of 81? Think back to grade 6. What does prime factorization mean? Well, think about what the word factor means. Factor are the two numbers that multiply together to get that answer, that product. And then prime means numbers that can only be divisible by 1 and itself. So let's find out what the prime factorization is of 81. I'll begin by drawing two lines like this. Two numbers that multiply together to get 81 are 9 and 9. Two numbers that multiply together to get 9 are 3 and 3. And the same thing here. Now I check to make sure these numbers are all prime, and they are. This could be one possible answer, or you may write it as 3 to the 4th power. Both of these answers work. And I didn't specify in the problem whether you were supposed to write it as exponents or factored out like this. Number 5. Take a minute and write down this question while I have a small chocolate break. If you could tell me what chocolate I'm eating in this video, what percentage it is, then I'll give you a prize ticket. Number 5. 2/3 x equals to 10. I'll begin by drawing a line through my equal sign. Since this line here means division, I can do keep, change, flip. These cancel out. Next, on the other side, I write a 1 underneath my 10 and do the same thing. Keep, change, flip. Now I'm multiplying fractions, so I'll do 10 times 3, which is 30, and 1 times 2, which is 2. This can be rewritten 30 over 2 as 15 over 1, or simply 15. So x is equal to 15. That was it for our daily review. Let's go back to our learning goal. I can identify possible solutions for inequalities. So today, instead of looking at things that are equal, such as this, x plus 2 equals 7, think about what could go in for x that could make the left side equal the right side. What plus 2 equals 7? 5 plus 2 equals 7. That's an equation. But if we look at inequalities, things that aren't equal, 3 plus 2 is greater than 4, so 5 is greater than 4. These things are not equal. Let's begin with some basic vocabulary. An inequality means two things are unequal. They're represented by a less than sign. Helps describe a number to be smaller than the other. It can also be represented by a greater than sign. Helps describe a number to be larger than the other. Now, way back in elementary, you'd be given an example like this, 9 and 10. And you'd be asked to identify which one is greater. You'd be given a problem like this in elementary, 9 and 10. Which one is greater? Your elementary teacher could have played this song for you.
There was an alligator living in the swamp. He'd sneak up on numbers and start to chomp. Whenever two numbers sat on the ground, she'd face the bigger one and gobble it down. When there are two numbers that are the same, the gator changes form and she swaps her name. Because she isn't sure exactly how to dine, she stands right in the middle as an equal sign. Number gators like to eat what's greater. They turn their backs on what is less. Their mouths open wide for the bigger side, and they munch down the whole great mess.
For more songs, games, and original stories, visit Brains.
So if you look at a number line, you can see that 9 is less than 10, or 10 is greater than 9. So then you can represent our inequality because 10 is greater than 9, like that. So 9 is less than 10, or 10 is greater than 9. Let's look at our second one, 8 and 7. Okay, well, I look at a number line, 8 and 7. Okay, 8 is greater than 7, so 8 is greater than 7. Or you can also think of this as 7 is less than 8. Number 3, negative 10 and negative 9. Well, I can see that negative 10 is right here in the number line, and negative 9 is about right here. Negative 9 is bigger than negative 10. And once again, the greater gator eats the bigger number. So negative 10 is less than negative 9. Number 4, negative 7 and negative 6. Once again, I can look at a number line, and I can see that negative 7 is over here and negative 6 is over here, so negative 6 is bigger than negative 7. So now I read this as negative 7 is less than negative 6. Number 5, negative 15 and negative 16. Negative 15 is right here, and negative 16 is right here. Okay, let's see. So that means negative 15 is greater than negative 16. So these are some things that were covered maybe in your previous grades, maybe not so much the negatives, but now we need to start talking about algebra and how this is represented, inequalities are represented in algebra. So let's reintroduce some vocabulary. An inequality that contains a variable is an algebraic inequality. A value of the variable that makes the inequality true is a solution of the inequality. Let's continue with our vocabulary. This can be represented with a greater than or equal to sign. The number x can either be the same or greater. You can remember the greater than sign because of the line underneath. Less than or equal to. The number in x is the same or less than to the second number. So if I place a number in for x for this example here, what number is either greater than or equal to 5? 5 would work. 5 is greater than or equal to 5. 6 is greater than or equal to 5. 7 is greater than or equal to 5. 8 is greater than or equal to 5. Do you notice a pattern here? Notice that there are many solutions for inequalities. The many solutions for an inequality are called the solution set. As opposed to equations which have one solution, there are many solutions for inequalities. Let's look at a less than. Less than or equal to sign. X is less than or equal to 6. Well, what numbers can go in for x that'll make this true? 5 is less than or equal to 6. 6 is less than or equal to 6. What other numbers make this true? 4 is less than or equal to 6. 3 is less than or equal to 6. So notice again, and this kind of looks like a face here, doesn't it? Notice that there are many solutions, and an infinite number of solutions for these inequalities here. The same can be also true for if we had x is greater than 6. What numbers can go in for x that make this true? 7 is greater than 6 is true. What about 6 is greater than 6? Well, that's not true. Notice the difference between this inequality here and this inequality. This means that it can be less than or equal for it to be true, and this means that it needs to be greater than or equal for it to be true. Let's do the same thing for greater than. Less than. X is less than 5. What are possible solutions for x? Well, 4 is a possible solution. 4 is less than 5. 3 is less than 5. And the solutions go on forever and ever and ever and ever. But notice that 5 is not a solution, because 5 is not less than 5. It's critical for you to remember the difference between greater than or equal to and simply greater than, or less than or equal to and simply less than. Because we're in algebra, now we have to slightly adjust how we think about inequalities. So based off our discussion about greater than or equal to, we want to slightly adjust our definition of what we've known as inequalities. We've said that inequalities means two things are unequal. Now we can think of an inequality that states two quantities are either not equal or may not be equal. An inequality uses the following symbols. In class, I will pass this paper out for you. If you need a minute, you can copy this down in your notebook. This is the less than sign. When we're talking about word phrases, fewer than or below, greater than, more than or above, less than or equal to is less than or equal to. This could be also referred to as at most or no more than. Greater than or equal to is a greater than or equal to sign. It could be referred to in words as at least or no less than. Once again, in algebra, instead of having two numbers given to us, such as 9 and 10, we're taking away one of those letters. So now we have x is greater than or equal to 7. X is greater than or equal to 7. So x, I write my x first, is greater than, then I have or equal to 7. What are some possible solutions to this inequality? Well, 7 is a possible solution because 7 is either greater than or equal to 7. 8 is a possible solution. And the numbers go on forever and ever. Number 2, it says x is less than 8. X is less than 8. Well, let's look back at this paper. The inequality sign goes in that direction. X is less than 8. And there we go. So what are some possible solutions for this inequality? 7 is less than 8. Negative 1,000 is less than 8. Negative 1,000,000 is less than 8. And again, the solutions go on forever and ever. Number 3, x is less than or equal to negative 4. My less than or equal to sign. So x is less than or equal to negative 4. What are some possible solutions for this inequality? Well, negative 4 is a solution. Negative 5 is a solution. And again, the numbers go on forever and ever. Once again, this is called your solution set. The set of solutions for this inequality. Number 4, x is less than or equal to negative 8. X less than or equal to negative 8. So what are some possible solutions for this inequality? Negative 8 is a possible solution. Negative 9 is a possible solution. Negative 10, and then the list goes on and on and on forever and ever and ever and ever. Again, that's called your solution set. Let's look at another example. It says the temperature today will be at most 50 degrees. If I look back at my chart here, it says that at most means less than or equal to. And if you think about it, when you're thinking about at most, it means it cannot go over 50. It cannot go over 50. 50 counts, but everything less than 50 will be a solution. So that looks like x is less than or equal to 50. So what are possible solutions for this inequality? Well, 50 would be a solution. 49 would be a solution. And then it goes on forever and ever. The sixth one. The temperature tomorrow will be above 70 degrees. So above 70 degrees, we'll begin with x. Above, okay, well if it's 70, that's not above. That's right out. So it has to be x is greater than 70. So what are possible solutions for this inequality? Well, 71 would be a solution. And then so on and so forth. 72. And that continues. Anything that's bigger than 70. The seventh one. Yesterday there was less than 2 inches of rain. Well, think about the less than sign. So I can say x is less than 2. So any number less than 2 would work for this inequality. Number 8. Last Monday there was at least 3 inches of rain. Now if I think back to my inequality paper here, it says at least means greater than or equal to. So when you think about at least, you can think about maybe your parents say, you have to get at least a P on your report card. Well, does that mean you can get a G? No. You can get a P, all the way up to an E. Once again, referring back to this, it says at least greater than or equal to. So x is greater than or equal to 3 inches of rain. So there can be 3 inches of rain, there could be 4 inches of rain, and so on and so forth. So let's summarize and wrap things up. X is greater than or equal to 7. What does this one mean? X is less than or equal to 7. X is less than 7, and x is greater than 7. Think about how you can tell the difference between greater than or equal to and simply just greater than. Remember, the line underneath the inequality sign tells you that it's going to be greater than or equal to or less than or equal to. Here's some practice we'll be focusing on in class. 7 is greater than v. Now, we haven't mentioned this in this lesson, but in future lessons, it's really important for us to understand that when we're writing our inequalities, the variable is on the left side. So I want to rewrite this then as v is less than 7. So I flipped the inequality sign in this example. So what are some possible solutions for this inequality? V is less than 7, so 1 is less than 7. 2 is less than 7. 7 less than 7? No, 7 is not less than 7. So those are our possible solutions for this inequality. Let's continue. So I recognize that my C is on the left side. So I have C is less than or equal to 6. So what numbers make this inequality true? Let's see, 1 is less than or equal to 6. 5 is less than or equal to 6. And 10 and 12 are larger than 6, so that doesn't work. So our possible solutions then are 1 and 5. Number 8. C is greater than or equal to 5. So what are the possible solutions that can make this inequality true? 11 is greater than or equal to 5. And I see that 5 is in fact greater than or equal to 5. So we have two solutions for this inequality. Number 9. 5 is greater than v. I'm going to rewrite this with the variable out front. And if I write my variable out front, I have to flip the inequality sign to have v is less than 5. So now we have v is less than 5. What are the possible solutions that make this true? Well, negative 4 is less than 5. 9 doesn't work. 1 is less than 5. And 8 is not less than 5. So we can say that negative 4 and 1 are both solutions to this inequality. So today we learned that inequalities are either not equal or may not be equal. We've slightly adjusted our definition from when we were in elementary from just two things to being unequal. They could possibly be unequal or they could possibly be equal. Today, we identified possible solutions for inequalities. Once again, here's some extra practice you can refer to help you solve inequalities. Thank you.